Hello viewers, you are welcome to Wisdom Global Learning and Training Academy. Today's video in chemistry will be focusing on electron arrangement. In our previous video, we talked about the atom, atomic structure, the mass number, and the atomic number. So today we'll be focusing on how the electrons in the shell are being arranged. Now, we said the electrons revolve around the shell. First, the shell that is closest to the nucleus is filled first. In the arrangement, for example, we said the electrons are arranged based on certain rule. We say the maximum number of electrons in the outermost shell will be 8 and the innermost is 2. And with a formula 2n squared. So if n is 1, you say 2 times 1 square. 1 square is 1 times 2 is 2. So the maximum number of electrons in the first shell, which is closest to the nucleus, is 2. And then subsequently is 8. So we have 8 electrons revolving around here. Okay? No. So that is that for that. Now let's take a look at each of the shell energy level, first, second, third energy level as it were right now, the shell, as they get closer to the nucleus of the atom. Because we say the electrons themselves, they are arranged in the shell revolving around the nucleus of the atom. Now in the first one, which is closest to the nucleus, let's take a look at how many electrons can be arranged there. Now we say 2. Why? Because we said from our formula 2n squared, the maximum number is for the first energy level, n will be equal to 1. N is 1 for the first energy level, so n will hold 2. If you take a look at the periodic table, you will be wondering why are the first two, in the first period there are only 2 elements. Why? Hydrogen and helium. Why are they the only 2 elements in the first period? Because they have only one element, which is equivalent to 2 elements, which is the maximum number of elements that can be held in that atom or in that period, so to say. Now the first shell in an atom holds a maximum of 2 electrons. The first shell, this is the first shell in an atom. It's holding a maximum of 2 electrons. Now the next shell is not going to hold 2, so the next shell will be what? 8. The second shell has an atom. The second shell in an atom holds a maximum number of 8 electrons. It holds a maximum number of 8 electrons because the next formula, the next rule is 2n raised to power 2. So it therefore means the number of electrons here will be 8. So subsequently 8 will be held in every subshell as it were. So 8 electrons will be held. If one shell is filled up, it automatically the electron goes to the next shell. If 8 is filled up in this shell, it goes to the third one, like as you see now in the third shell. Now in the third shell, the number of electrons, the maximum only in the third shell will also be 8. But at this point, the total electrons will now be 2 plus 8, which is 18. So if you slot in your formula 2n raised to power 3, 2 times 3 raised to power 2, you will get 18, which is because n at this point in time is 3. So the maximum number of electrons up to the third shell is 18. But the number of electrons that are found in each of these shell or energy level is 8 maximum. The first one can only hold 2 electrons. Is that okay? So these are the electron shells, and these are the shells in which the electrons are being arranged and they revolve around the nucleus of the atom. Now we proceed to and see this in just looking at the periodic table itself, a preliminary periodic table, like making use of the first 20 elements. If you take a look at the first 20 elements, for example, hydrogen has a number of electrons 1. Why? Because the atomic number is 1. So if the atomic number is 1, then therefore the number of electrons is 1. And therefore helium, what's the number of electrons we have, as we can see here, because the atomic number is 2, then the number of electrons is 2. So and so on and so forth. So this is how they've been arranged according to the atomic number, which is also equal to the number of electrons. 1, 2, helium is 2, lithium is 3, beryllium is 4, boron is 5, carbon is 6, nitrogen is 7, oxygen is 8, fluorine is 9, neon is 10, sodium is 11, magnesium is 12, aluminium is 30, silicon is 40, phosphorus is 50, sulfur is 16, chlorine is 17, argon is 18, potassium is 19, and calcium is 20. I know you'll be wondering these symbols, what they mean. Don't worry, we're going to make a video on chemical elements and their symbols. How potassium became K, how calcium or sodium became Na. We're going to talk about this in one of our videos. Now let's move ahead and take a look at the shell. Which element or which atom is shown by the electron arrangement? Now we've given you an electron arrangement. We've shown you an arrangement. We said electrons are arranged in the shell revolving around the nucleus of the atom. Now the first shell in this case has 2 electrons, and the next one also has 2 electrons. So 2 plus 2 is 4. So which element or which atom has 4 electrons, which is also equal to number of proton 4? So which is it? Helium? No. Is it beryllium? Boron? No. Is it beryllium? Yes, because the atomic number is 4 and the number of electrons is 4. The number of protons is 4. Is that okay? So great. You see, that's great. Now we move on to the next atom. If you take a look at this atomic arrangement, let's take a look at this atomic arrangement, and then you tell us from the electron arrangement which atom is this or which element is this. Which atom is shown by this electron arrangement? Take a look at this. The first shell has maximum of 2 electrons, this, which is this and this. Then the second one has 8. So 2 plus 8 is 10. Then the next one has how many? 1, 2, 3, 4, 5, 6, 7, 8. So which means 2 plus 8 plus 8, which is 18. Which one? Which atom? Argon. That's great. So this is how electrons are being arranged in the shell or in the orbit. How they be arranged? The first one is 2, maximum is 2. The next one is 8 and 8 subsequently. It doesn't mean that the outermost electron must be 8. If it's 8, it means it's already obeying octet rule. It means it becomes an inert gas or inert substance, which means it doesn't need to react anymore because it's stable. If it has 8 in the outermost shell already, it means it's a stable atom. It doesn't need to react, because the reason why they react is to fulfill the righteousness of having stability. Because we said for an electron or an atom to be stable, it has to have 8 electron in the outermost shell, in the shell. So if it's already having 8, it's very relatively unreactive. It's not that reactive as it were. But if we have, for example, we have 2 here and we have 8 here and we have 1 here in the outermost shell, then we begin to talk about sodium, because the atomic number is 11. Because then we have 2 plus 8 plus 1. That will be 11, which will be sodium. So the number of electrons as they've been arranged in the shell or in the orbit also can determine the element or the atom that we're talking about. Okay, so that's great, and that's for this video. You watch out for our next video, which is going to talk about the periodic table and the electrons in the periodic table.